are welcome to this physics class. This time around, we are going to be considering past question of previous JAMB question in physics. That's talking about the year 2008, please. It's 2008 we are considering. So we'll be considering 2008. In 2008, we are going to consider 10 different questions. So which will cover different topics such as mechanics, light, electricity, nuclear physics. So first, we are going to go with the first four on the board. For that very year, 2008, we have the number 3 goes this way. The resultant of two forces, 12 Newton and 5 Newton, is 13 Newton. So with this statement alone, we have that the resultant of these two forces, 12 Newton and 5 Newton, we are told that the resultant is 13 Newton. What is the angle between the two forces? So for a resultant of forces to be 13, that's coming to this place, we are told that it's 13 Newton. So for resultant of any force to be 13, this is resultant. Hence, the two forces must be in perpendicular. That's angle 90 degree is what is joining them. Because from Pythagoras, the square of this plus the square of this, square of 12 is 144, square of 5 is 25. Putting them together, we are going to get 169. Root of 169 is 13. So hence, if resultant of two forces is a 13, so that means the angle between them should be 90 degree. So coming to the option, C will be the right option. Let's go for number 4 of that year. It's still under mechanics. We are told that which of the following is not, take note, the word not, a vector quantity. Vector quantity, we know that they should be quantity, they have both magnitude and direction, and that's what differentiates them from scalar quantity. Scalar quantity only have magnitude, no direction. The meaning of magnitude is size of a quantity. Now, which of them will have both magnitude and direction? We have altitude. Altitude is an height. Altitude is an height. Let's take for instance, if this is a building. If this is a building, then you are talking about altitude. That means you are talking about the height. Will height be a vector quantity? No. Height is just a distance, and distance are under scalar quantity, not vector quantity. So now look at acceleration, displacement, weight. Both B, C, and D, they are vector. Only the one that is not vector is altitude. Number 7 of that very year. A body of mass 4 kg rests on a smooth horizontal plane. Yes, a body of mass 4 kg. By illustration, you have a body. The mass of the body is 4 kg. So weight should be mass times gravity, meaning that the weight should be, the mass is 4 times 10, that is 40 Newton. So that's all you can get from there. The body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces. Two perpendicular forces, that means one is going this way, another one is up, making them perpendicular. That's forces that are angle 90 degree to each other. Forces 6 Newton and 8 Newton. Yes, 6 Newton, 8 Newton. We are now asked to calculate the acceleration of this motion. What can unite force alongside weight to give acceleration? So that means you go for Newton's second law, which is F is equal to ma. But in this case, this is g. So for it to have acceleration, if these two forces, either they are pulling it or they are pulling it. So but we are not told whether they are pulling. So let's assume the two forces are pulling this. So the motion should be this way. So for these two forces to pull a weight of 4 kilogram, we have F is equal to ma. So the mass is 4. The acceleration is unknown. But this force, we are going to calculate them from here. Since the forces are in perpendicular, hence you have to resolve them to be single force. A force is going up, another one is coming this way, perpendicularly. Take note of the language. We are told that the forces are perpendicular. You have to resolve them to be single force. This is the main knowledge being tested. How can you resolve two forces to be a single force? So that means you find the resultant of them. You are going to use the resultant of these two forces. Resultant of these two forces now is this, and that's what you are going to use. So that means instead of F is equal to ma, you are using the resultant of R is equal to ma, where you already know that your m is 4. So what's the resultant of this? This is already a right angle triangle, as you can see. So you are having the resultant, you are having 8, you are having 6. To find this, so that means we are going to go with Pythagoras. 8 squared plus 6 squared. So resultant will be root of, this is 64 plus 36. So root of 100 should be 10 Newton. Hence, the resultant force, which will be the force that can pull this 4 kg weight, will be 10 Newton. So in place of force here now, you have 10 Newton equals to 4a. So divide both sides by 4. That means our acceleration will what? 10 over 4. 10 over 4 should be 2.5 meter per second square. Now going for the options, you see that option A is the correct answer. So we have number 13 for that very year. A motorcycle. A motorcycle of mass 100 kg. The motorcycle, the mass is 100 kg. Move round a cycle. Okay, this is number 13 for that very year. The motorcycle was of mass 100 kg. So mass of the motorcycle is 100 kg. Moving around in a cycle. So when you find a word like this, that's motion around the cycle, that's circular motion. With radius, so the motorcycle is moving around this cycle. So the radius of the cycle is given as 10 meter. So radius given is 10 meter. With a velocity of, so we are giving velocity to, of 5 meter per second. So making 3 variables we are giving. The motorcycle has a mass 100 kilogram. The radius of the cycle is passing through is 10 meter. The velocity of its movement is 5 meter per second. We are now asked to find the coefficient of friction. Coefficient of friction between the road and the tire. Yes, friction is the force that opposes motion. So between the tire of the motorcycle and the road, there is friction that is bound to occur. So, but what is the formula we are using to find the coefficient of friction? And that will be a form of coefficient of dynamic friction due to motion. So, frictional force is equal to mu r. This is the formula. Frictional force is equal to mu r. So, our mu represents the coefficient of friction. So, if we make use of a formula, so the frictional force that is going over normal reaction. Now, the force, the type of force that is occurring in a circular motion like this will be a centripetal force. Hence, this can easily be converted to the force now this time around is centripetal force over R. Now, as for the normal reaction, it's going to be the weight of the vehicle. Weight times gravity. So if you pick it one after the other, the normal reaction here is going to be mg, which is the mass 100 times 10, everything is 1000 Newton. That's it for the normal reaction. As for the centripetal force, the formula for our centripetal force here is mv squared over r. What is the mass? The mass is 100 the velocity of movement is 5 and that is a square over the radius is 10. So you are having two different formulas now to use. The formula relating the coefficient of friction, which has normal reaction and frictional force, but the type of force that is occurring here is a form of centripetal force. So for our normal reaction, we are having mg, which we have calculated. For our centripetal force now, we are having this formula mv square over r. Let's now get the answer to this. This will be 25 times, that's 25, 2500 over 10. Then we are having 250. So putting it together now, our centripetal force is 250, our normal reaction is 1000. So the coefficient of friction, which is a ratio of the centripetal force and the normal reaction now, that means we put them together, telling us that we're having 250 over 1000. So this is 25 here 1, 25 here 4, 1 over 4. 1 over 4 should be 0.25, and that should be option D. We are going to consider the other questions right now. Okay, let's continue with number 26 of that year. It's a question under wave, and that's why we will choose random 10 so that we can cover various topics. If not, we have just done number 1 to 10 alone. So number 26 is wave motion. We are given this general wave equation. We are given that y equals to 5 sine 200 by t minus 0.4x. Good. We are now asked to calculate the wavelength. The symbol of wavelength is lambda. We are asked to find the lambda. Now you will recall that the general wave equation, to put this side by side, is a sine 2 pi, if you are having this, 2 pi vt over lambda minus 2 pi ft, like this, or 2 pi x, yes, 2 pi x. So now you are having it to be 2 pi x, then to be over lambda as well. 2 pi x over lambda minus 2 pi ft, or 2 pi vt over lambda. So in this essence now, we will take note that which one can easily relate to each other. So it's going to be this that's related to this. Now if the wave speed is asked, then you can use this directly with this. But in this case, the lambda is being asked, so you compare both equations. So this is for this. Assuming the amplitude is being asked, the amplitude is 5, but now you are asked of a wavelength. So these two, let them work together. What we are saying is they are going to say 2 pi x over lambda equals to 0.4x. So in this case now, when you cross multiply, you have 2 pi x is equal to 0.4x times lambda. So easily x can cancel x. Then you are left with 2 pi equals to 0.4 lambda. Doing this together, we make lambda to a formula. That means you divide both sides by 0.4. So lambda is 2 pi over 0.4. We do this very well. So that means 2 here 1, 2 here becomes lambda over 0.2. So what is going to be lambda over 0.2? That's 3.142 over 0.2, because that's the value of lambda. So 3.142 over 2. Let's see what we can get as our answer. 3.142 over 2. So that is 1.57, giving us 1.57. I guess this would be a mistake. It should be 1.57. So after pressing calculating for 3.142 over 0.2, you are going to get 15.7. So either you press it directly as 2 times 3.142 over 0.4, you are going to get this, or you say you have divided and have 3.142 over 0.2, you still have 15.7 as the answer. Now let's go for the number 31 of that same year. 31 of that same year, an object of height 4 cm is placed in front of a cuboid Pinot camera. Good. This is a question under light wave. So a cuboid should look like this, and it's a Pinot camera. This is the hole of the camera, but the object height is 4 cm. So you're having an object which height is 4 cm. So you expect the image of the object to be formed this way. So to be lateral inverted. So the object height is 4 cm, placed in front of a cuboid Pinot camera of size. So the size of the camera is going to be the length from here. We are given to be 6 cm. That's the length of the camera. If image form is 2 cm high, so that means this image that is formed here is 2 cm high from the Pinot camera. How far? Okay. Now the question now says, how far is the object from the Pinot camera? Yes, the distance between the camera and the object, which is u, object distance, that is what we are looking for. So the object distance from the spot of the object to the camera is what we are looking for. So what formula can easily join object height, object distance, image distance, and image height together? That is talking about magnification. And try to remember that the formula for magnification is, our m is v over u, which is image distance over object distance, which is same thing as image height over object height. So putting these four variables together, we can easily calculate for the object distance. Let's put them together. Image distance is 6 now. That is the length of the camera. So 6 over object distance is what we are looking for, equals to image height. The image height is 2 over object height is 4. So easily, when you cross multiply, 2u is equal to 6 times 4. So divide both sides by 2. That means 2 cancel 2. That means object distance is going to be 2 here, 1, 6 here. 2 here is 3. 3 times 4 is 12 centimeter. Meaning that the distance here is 12 centimeter. So the object distance is 12 centimeter. That is option C. Let's move on. Number 44 of that same year. This is a question under electricity, the aspect of AC circuit, and these are inductors in a circuit. The arrangement is series connection like this. So they are connected in series. So their effective inductance that is being asked here is going to be the sum of, if we label it to be L1, L2, L3. So that means you sum them all. You are going to have L1 plus L2 plus L3. So it is a matter of summing the inductors together. L1 plus L2 plus L3. But mind you, if this were to be capacitors, there is going to be 1 over C1 plus 1 over C2 plus 1 over C3. But either inductor or a resistor, you add them in their sequence. So that is simply 5 plus 10 plus 20, and this should be 35. So 35 millihenry is our answer. It's a very simple one. You only want to test if you understand it in series and parallel connection. Let's move on to the next one. This is a question under radioactivity. That's talking about nuclear physics. And in this is a form of alpha decay, where helium represents alpha particle. So it's number 46 for that very year. We're having that when helium reacts with nitrogen, oxygen isotope was produced plus a particular element. So we are asked that in the equation above, the particle X is, so how can we know what particle X is? If it was to be a beta particle is electron 0 minus 1. Alpha particle is helium 42, and then a proton is P11, and neutron is 10. So which of them will result from this? So it's a matter of balancing the equation. If you are balancing, 14 plus 4 will give 18. That's talking about the mass number. So 17 plus x plus a particular number, we need these ones to also give us 18. So when you make SL formula, it's going to be 18 minus 17. This is 1. Come to the atomic number. 7 plus 2 is 9. Then 8 plus x. So 8 plus x should also give us 9 to balance it up. So that means s is 9 minus 8, 1 as well. So when you check this is simply neutron 1. Neutron, proton 1. So that means the answer is A, proton 1. So we have 2 more questions to round up this class. Okay, the remaining 2 questions we are going to consider, this is number 35, this is number 49. They are not calculation questions. However, they are testing our knowledge of understanding of those concepts. This one is under properties of, that's talking about properties of wave. Don't forget, we have 5 of them. So they are, we have refraction, reflection, diffraction. 4, we have polarization. Then we have interference. So here, refraction is when rays of wave, when they change in the direction, when crossing boundary, change in the speed and direction. Reflection is bouncing back when it meets a non-transparent object that is talking about opaque. Diffraction is bending around obstacle. So when waves are meant to bend around obstacle. So when a wave encounters barrier, then it will bend around the obstacle. So that's diffraction. Polarization is making wave, instead of wave that is vibrating in various planes, make a wave to vibrate in only one plane. That's concept of polarization, and use a polaroid for it. That's talking about a polarizer. So interference is, you can either have it to be constructive or destructive interference, or that's talking about superposition, when you make wave that is traveling to superimpose. So let's now look at what this question is talking. An object placed at the bottom of a well full of clear water. So if this is the well, an object is placed here, so full of clear water for visibility, appear closer to the surface. So these objects appear to be around there when viewed from top like this. So this is the eye view. So what is that concept called? It is a concept under refraction, because that's talking about real depth and apparent depth. Where the object is the real depth. Where it appears to be is the apparent depth. So that's talking about refraction. Refraction makes that to occur. You can test that at home too. You place any object below a cup of water and view it from the top, you see that it appears to be up than the way it is. Lastly, when a pure semiconductor, this is talking about electronics, a pure semiconductor is heated, its resistance does what? Now before we pick our option, know that semiconductor has conductivity between a pure conductor and insulator. So if you are to be that you heat a pure conductor, it makes the resistance to increase. But if you heat a pure semiconductor, the conductivity will increase. So where is the focus of this? It's focusing on the resistance. So if the conductivity will increase, then that means the resistance will decrease. However, it's the reverse for a pure conductor. A pure conductor, when heated, the resistance will increase and the conductivity will decrease. So that's it about the few questions we want to solve in year 2008 physics past question.